Welcome to the course, A Foundation for Machine Learning and Data Science, section Statistics Overview. In this section, we will be reviewing what is statistics, why do we need to learn statistics, what are statistical models, what are the different types of statistics available, what are mean, median, mode, quartiles, and percentiles, what are range, variance, and standard deviation, what are skewness and kurtosis, what are the different types of variables we will be dealing with, and finally, how statistics is used in various stages of machine learning. What is statistics? In simple terms, we can define statistics as a subfield of mathematics, and it refers to a collection of tools and methods for working with the data to answer questions. Why do we need to learn statistics? It is generally considered a prerequisite to the field of applied machine learning. It's used to help transform data into information and to answer questions about samples of data. It's also used to summarize data and quantify properties of a domain given a sample data. Therefore, statistics is required to understand the data used to train an ML model and to interpret the results of testing different ML models. What is a statistical population? A data population is all possible observations that could be made, and it's abstract. The notation is capital N. Generally, when you work with data, you work with a sample of the population. The notation is small n. When you are working on a prediction problem, you are working to best leverage a sample to characterize the population so that you minimize the errors in the predictions you make from other samples your system will encounter. You must be careful in selecting and handling your sample. Means the size and qualities of the data will affect your ability to effectively characterize the problem, describe the data, or make predictions. Let's try to understand the population and the sample with an example. Population means the entire data set. Sample means a subset of the population. Care must be taken for selecting a sample. The sample must be the true representation of the population. What is true representation? Let's say we have a fruits dataset with 10,000 rows which has the details of 10 different fruits. Say apple has 1,000 rows, orange has 1,000 rows, and so on. So the population is equal to 100% of data, that is 10,000 rows for 10 distinct fruits. Say we select 80% of the population as sample 1. The sample 1 is equal to 80% of the data, that is 8,000 rows. Here, the first 8,000 rows were selected containing the details of the first 8 fruits only. This sample does not contain the details of the last 2 fruits, and hence it is not the true representation of the population. Any analysis we do, any information we extract from this data set, and any decision we make based on the extracted information will be wrong. On the other hand, say we select another sample called sample 2 with 80% of the population, that is 8,000 rows, same as sample 1. But this time we select 800 rows from fruit 1, 800 rows from fruit 2, 800 rows from fruit 3, and so on. This sample would contain the details of all 10 fruits, and hence it is the true representation of the population. Any analysis we do, any information we extract from this dataset, and any decision we make based on the extracted information will make sense and will be useful. Therefore, it is important that we select samples from the population. We ensure that we select data from all categories of data available in the population instead of randomly selecting some percentage of the population data. What are statistical models? In statistical terms, a model is a simplification of a process which could always be wrong, but it could be useful. A statistical model describes the relationship between data attributes such as a dependent variable with independent variables. You can run ML algorithms that assume a type of model of a specific form will describe the relationship and find the parameters to fit the model to the data. The notations used here are good fit, overfit, and underfit, where the model is too specific or not specific enough in its ability to generalize beyond observed data. Simpler models are easier to understand and use than complex models. So start with the simpler models and increase complexity as needed. An analogy. Using a country map to drive from one street to another. This is called underfit because the model is too simple and cannot be used for the purpose. Then using a street map to drive from one state to another. This is called overfit because the model is too complex and too difficult to understand and use. Then using a highway map to drive from one state to another. This is called good fit because the model is neither simple nor too complex and will serve the purpose. On the side note, raw observations are data, processed data is information, therefore processed raw data is equal to information. One of the main purposes of ML is to extract meaningful information from the given dataset for decision making. Let's see what are different types of statistics available. Broadly, statistics can be divided into two types: theoretical statistics and applied statistics. Theoretical statistics is outside the scope of discourse, so we won't be talking about it any further. The applied statistics can be further divided into descriptive statistics and inferential statistics. Descriptive statistics deals with organizing, understanding, summarizing, and presenting data using text, tables, charts, and graphs. Inferential statistics deals with drawing conclusions about a population based on the data observed in a sample. Descriptive statistics is used to measure the central tendency in the dataset, measure the dispersion or the variation in the dataset, and measure the shape of the dataset. Mean, median, mode, and quartiles are used to measure the central tendency. Range, variance, and standard deviation are used to measure the dispersion. Skewness and kurtosis are used to measure the shape. Inferential statistics is used to generalize from samples to populations, determine relationships, hypothesis testing, and make predictions. Let's dive deeper into mean, median, mode, quartiles, percentiles, etc. Mean is nothing but the average value of all the data in the dataset. The formula for mean is the sum of all data in the dataset divided by the total number of data points in the dataset. Let's say we have three datasets, X, Y, and Z. If we pick X, then N becomes 7. If you do the arithmetic, you will get 5 as the mean. Median is the middle data point in the dataset. The procedure to find the median is as follows. Sort the dataset in ascending order. If the number of data points is odd, the median is the middle data point in the dataset. If the number of data points is even, the median is the average of the two middle data points in the dataset. If we pick X, then N is 7, then the sorted X is 1, 4, 4, 4, 6, 6, and 10, and the median is 4. If we pick Y, then N is 8, then the sorted Y is 1, 2, 4, 4, 6, 6, 6, and 10, and the median is 4 plus 6 by 2, which is equal to 5. Mode is the most frequently occurring data point in a data set. If we pick x, then n is 7, 10 occurs one time, 6 occurs two times, 4 occurs three times, and 1 occurs one time. Hence, the mode is 4. If we pick z, then n is 9. Here, 10 occurs one time, 6 occurs three times, 4 occurs three times, 1 occurs one time, and 2 occurs one time. Hence, the mode is 4 and 6. How to find quartiles? Sort the dataset in ascending order. Divide the sorted dataset into 4 equal parts, that is 4 quarters of 25% each. The data points in each part are called a quartile. The first quartile Q1 is 25% of the data lies below the first, that is lower quartile, also known as 25th percentile. Median Q2, the midpoint of the data set, that is half of the values lie below it and half above, also known as 50th percentile. The third quartile Q3 is 75% of the data lies below the third, that is upper quartile, also known as 75th percentile. Then what is percentile? A type of quartile that sorts and divides the dataset into 100 equal parts, with each part representing 1% of the data. Let's try to understand quartiles and percentiles with an illustration. To find out the quartiles and percentiles, we need to first sort the dataset in ascending order. After sorting is done, we plot the data points and get a normal distribution curve like this. We divide the sorted dataset into 4 equal parts, each having 25% of the data. The first part is called Q1, that is first quartile. The second part is called Q2, that is the second quartile. It's also called the median. The third part is called Q3, that is third quartile. We don't normally call the last quarter as Q4. Let's see what percentiles are. The first 1% of the data is called the first percentile. The first 2% of the data is called the second percentile. The first 3% of the data is called the third percentile, and so on. The first 25% of the data is called the 25th percentile. The first 50% of the data is called the 50th percentile. The first 75% of the data is called the 75th percentile. The 100% of the data is called the 100th percentile. The difference between the third quartile and the first quartile is called the interquartile range, IQR. What are range, variance, and standard deviation? Range is the difference between the maximum value and the minimum value in the data set. The formula is range is equal to the maximum value minus the minimum value. Let's say we have a data set called X, then the range is 10 minus 1, which is equal to 9. Variance. Variance is the sum of squared differences between the individual data values and the mean divided by the total number of data points in the data set. The formula is variance sigma square is equal to sum of xi minus x bar whole square divided by n, where xi is an individual data value, x bar is the mean, n is the total number of data points in the data set. Standard deviation. Standard deviation is the measure of the amount of variation between each data point from the mean. Formula is standard deviation is equal to square root of variance. Let's try to understand the standard deviation with an illustration. Let's say we plot the given data points and get a normal distribution curve like this. The middle point is the mean and the standard deviation at this point is 0. The values of half of the data points will be lesser than the mean and will fall on the left side of the mean. The values of the other half will be greater than the mean and will fall on the right side of the mean. Hence, the deviations on the left side will be negative and the deviations on the right side will be positive. As per the empirical rule, that is 3 sigma rule, that is a 68, 95 and 99.7 rule, 68.27% of the data points will fall within the 1 standard deviation, 95.45% of the data points will fall within 2 standard deviation, 99.73% of the data points will fall within the 3 standard deviation. Therefore, almost all the observed data will fall within 3 standard deviations. What is skew? A skew describes how data are distributed and their directions. It helps us to understand the relationships between mean, median, and mode. It also helps us to understand the shape and outliers in the dataset. There are 3 types of skews. No skew, which is a normal distribution. In a no skew distribution, the mean, median, and mode will be the same. The no skew is also called the normal distribution, Gaussian distribution, or symmetrical distribution. Positive skew, where the distribution has a long right tail. In a positive skew distribution, the mean is greater than the median and the median is greater than the mode. Positive skew is also called right skewed. Negative skew, where the distribution has a long left tail. In a negative skew distribution, the mean is less than the median and the median is less than the mode. Negative skew is also called left skewed. What is kurtosis? Kurtosis describes how heavily the tails of a distribution differ from the tails of a normal distribution. It provides information about the tails and peaks of the distribution compared to a normal distribution. It helps to identify the outliers. There are 3 types of kurtosis and they are mesokurtic, that is zero kurtosis, leptokurtic, that is positive kurtosis, then platykurtic, that is negative kurtosis. Let's say we have 3 distribution curves like this. The curve in the middle is mesokurtic, the tall curve is the leptokurtic, and the shortest curve is the platykurtic. This table describes the properties of these 3 kurtoses: mesokurtic, leptokurtic, and platykurtic. Tail: medium-tailed, heavy-tailed, and flat-tailed. Outlier frequency: medium, high, and low. Kurtosis: moderate, high, and low. Excess kurtosis: 0, positive, and negative. Distribution: normal, Laplace, and uniform. Then what's the difference between skewness and kurtosis? Skewness is the measure of the symmetry of the distribution, whereas the kurtosis is the measure of the heaviness of the distribution tails. If you look at the diagram, all 3 curves have symmetrical distribution that is measured by the skewness. Their tails and peaks of distribution are different that are measured by kurtosis. Let's see what are the different types of variables we will be dealing with. Numeric variable, also known as quantitative variable, contains only the numerical value. Integer variable, also known as discrete variable. A whole number that has a finite number of countable values between any two values. Example, floor numbers in elevators or lifts, -1, -2, -3 to refer basements, 0 to refer the ground floor, 1, 2, 3 to represent the floor numbers accordingly. Values can be positive, negative, or 0. 0 is neither positive nor negative. Float variable, also known as continuous variable. It's a fractional number that has a finite number of countable values between any two values. Example, price, $99.99, $78.5, $0, etc., or discount such as -$10.5 or -$25.5, etc. The measurement scale is equidistant, that means equally spaced. Values can be positive, negative, or 0. Interval variable. A float variable that has no true zero value means 0 is a valid value. Example, temperature. Below 10 degrees centigrade, 0 degree, or above 10 degrees centigrade. It supports only additions and subtractions. Other arithmetic operations cannot be performed. Values can be positive, negative, or 0. Ratio variable. A float variable that has a true zero value means 0 is not a valid number. Example, height and weight cannot be 0. Values can be positive and cannot have negative values. Categorical variable, also known as qualitative variable, contains only non-numerical fixed value. Nominal variable. A variable that has two or more categories. Example, gender, male, female, color, red, green, blue, or phone number. There is no ordering involved with this type of variable, and there is no agreed way to order these from highest to lowest. The numbers are used here only to categorize or identify objects. These variables can also take quantitative values. However, these quantitative values do not have numerical properties, that is, arithmetic operations cannot be performed on them. Only mode can be performed or analyzed. They can be visualized using bar charts, pie charts, etc. Ordinal variable. It's an extension of nominal data and it has a rank or order. There are two types of ordinal variables. Ordinal variable with a numeric value. Example, what is your income group on a scale of 1 to 3, where 1 refers to low, 2 refers to medium, and 3 refers to high. Then ordinal variable without a numerical value. An example, what is your income group? Low, medium, high. Mean, median, mode, quartiles, percentiles, etc. can be performed or analyzed. They can be visualized using bar charts, pie charts, etc. Boolean variable. It's a variable that has only two states, such as true or false, yes or no, 1 or 0. Example, have you learned machine learning yet? Yes or no. This is a Boolean variable. Let's summarize the variable types. Broadly, the variables can be grouped into two categories, numeric and categorical, that is quantitative and qualitative. The numeric variables can be categorized into integer and float, that is discrete and continuous variables. The float variables can further be categorized into interval and ratio variables. The categorical variables can be categorized into nominal, ordinal, and Boolean variables. There are two types of ordinal variables, one with numeric value and the other without numeric value. Let's see how statistics is used in machine learning. Earlier we saw that there are 11 stages involved in an ML project. Statistics is used in some of these stages Let's understand which ones are they. Statistics in data understanding. Descriptive statistics to understand the raw data using mean, median, mode, quartile, range, variance, standard deviation, etc. Visualizations to understand each attribute and the relationships between them using bar charts, pie charts, histograms, etc. during the exploratory data analysis. Statistics in data preparation, that is, methods required to prepare the training and test data for the ML models, or outlier detection and removal, missing value imputation, both numerical and categorical, data sampling, data transformations, transforming numerical type, that is normalization, standardization, data scaling, etc., and transforming categorical type, that is variable encoding, one-hot, label, ordinal, etc. Statistics in model evaluation, that is methods required to evaluate the skill of an ML model on data not seen during training, or data sampling, data resampling, that is k-fold cross-validation techniques. Statistics in model selection, that is methods required when selecting a final model to use for a predictive modeling problem, or checking for a significant difference between results, quantifying the size of the difference between results. Statistics in model presentation, that is methods required when presenting the skill of a final model to stakeholders, or quantifying and summarizing the expected prediction skill of the ML model on average. Statistics in prediction, that is methods required when making a prediction with a finalized model on new data, or quantifying the expected variability for the prediction. With this, I'll conclude this video and I'll see you in my next video, probability overview. If you have not done so yet, please rate and comment on this course, as they will mean a lot to me. Thank you.